Hey guys, so I'm just revising a question from the review session, right? I didn't write it clearly and I didn't explain it enough to a point where like I felt like it was understandable. So also keep in mind in my original video, I misspoke for this question, not this question, but this question, right? So in the video, instead of saying like over here, instead of saying addition, I said subtract. I did add it in the calculator, right? But I didn't clarify that. So I'm just clarifying it now. 602 plus 432. All right. So I did do it in a calculator. I did add it in my calculator, right? Like over here, instead of doing subtract, I did add, right? And I got 103, and that is correct. But I didn't say that here, okay? So, okay, let me revise this question. One with the N, this one. N2H4 plus N22H, right? Estimating the change of H in bond energies. So let me revise that, okay? So I'm gonna firstly make the Lewis structure for N2H4. Okay. N2H4. So that is being going to N2 plus 2 H2s, right? So what I made a mistake with in the review section was that I made a triple bond instead of making a single bond. So let's say we have a valence electrons of 5, right? We have a valence electron of 5 for a neutron, right? Not neutron, nitrogen. 1, 2, 3, 4, 5, right? And 1, 2, 3, 4, 5. So instead of making a single bond like I'm supposed to, I made a double, like triple bond. 1, 2, 3, right? And I connected the hydrogens, right? But that is not what it's supposed to be, right? This is wrong. Before we even make a bond, we have to consider the lone pairs, right? For this question specifically. So, so we have N2 plus 4, right? And 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we're connecting the lone pairs first. So we're connecting like this. We only have one single bond. Connecting the lone pairs and connecting to 4 H's. So 1, 2, 3, 4. And the hydrogen only has one valence electron. So all of this matches, right? And the product is going, not product, but it's this is the being formed like that. N2 plus 2H2, right? And let's make a Lewis structure for N2, right? Okay. So let's make a Lewis structure for N2. 1, 2. But here we can have a triple bond because this is not being paired up with 2 H of 2s, right? This is just it's separated it, right? So we don't have to worry about that right now. So 1, 2, 3, 4, 5, right? So we can have a triple bond here. 1, 2, 3, 4, 5. So this can be connected to this can be connected with this, and this can be connected with this. And these gonna be a lone pair, and this is gonna be a lone pair. And we call it a day. And we have 2 of H's, so we are adding 2 H's, right? So, and also these are also separated. It's not combined. It's just like 2 of H's. So now we let me rewrite this more clearly. All right, so it's gonna be like 1, 2, 3, and we're gonna have plus 2 hydrogen bonds. Right. Okay. And this is going from here. So okay, so this structure is going from this to this, right? So we have to calculate the number of bond that's been broken. Bond broken. So to make the triple bond here, we had to break a single bond here, right? So let's write that down. To make a double bond, like singular double bond of HH, we had to break it here. So we had to break everything here. N. Okay, so bond being formed. So we have triple bond being formed here. And we have 2 H's being formed here. All right, let me write down the energy for each one. So the energy chart is going to be 386. And I got these numbers from the table. One, two, three, four. Just making sure. 1, 2, 3. So it should equal to, okay. The total is 170. Okay, 1,711. All right, so triple bond of that is 942. Where's on 432. Where's on the total for that is 942 plus 942 plus 4 108 1806 177 1711 minus 186 is equal to -95. So yeah, guys, this is how you do this question. We record the number of bond that was being broken and record the number of bond that's been formed and calculate their energies like that and see the change of energy, change of energy, but this is a change of energy, like change of bond energies like that. Just be very careful when you make the bonds and single bonds and lectures and whatnot. All right, thank you.